By the end of this tutorial, you will learn everything related to the React SWR package. I guarantee that you will understand every concept of this library and will be ready to start working with it. You will learn about data fetching and mutations, caching, revalidating, pagination, infinite scrolling, optimistic UI, config providers, error handling, middlewares, and much more. We are going to use Next.js here, but you can also use it in a React project. There's no difference between them in this tutorial. SWR or State While Revalidate is an amazing, simple, lightweight React library with hooks for data fetching on the client side. It aims to solve problems such as caching, revalidation, and performance improvement. By using the SWR library, you can simplify data fetching, handle caching, error handling, and it's particularly useful for efficiently fetching data from various APIs, managing a state, and handling complex data fetching logic as the application grows. SWR is built upon the State While Revalidate strategy, which helps ensure that up-to-date data is always displayed to users. If your application has many API endpoints or is constantly making changes to the server database, it's a very wise choice to use this library. So let's get started. But before we continue, please consider liking and subscribing to my channel, as it really helps my career on YouTube to continue. So don't forget to like and subscribe. Just head over to your favorite IDE and create a simple Next.js project like this. You're using TypeScript, we want ESLint, we don't want Tailwind, no. You're using app router, and no. Just wait for it to get installed. Just after your project is built, head over to the File Explorer, go to the app folder, remove all CSS files here, just because we want a very simple project and we are not going to use CSS here. So remove them, head over to the layout, just let me make it a little bit smaller, remove globals.css file here, go to the page and also remove page.module.css here. Also remove all of this like this and create a simple div with the text of hello world here. Remove this redundant import also. After that, just run the project like this, and as you can see here, everything is working correctly. For you to better understand what types of problems this amazing library, the SWR library, is solving, we just simply need to create an example and fetch data from our server the old way without using the SWR library. And because of that, I'm running a very simple fake backend on the port 8080 of my terminal here. As you can see, there is nothing fancy here. We're just simply fetching the list of to-dos here, the user's cart, products, posts, and many things like this. You can find the link to the backend server and also the final React SWR project in the description below. So we head over to our application here. Just let me make it a little bit bigger for you to see better. In your app folder, create another folder called components for better organization. Inside it, create a file, for example, old.tsx, because we are going to show you the old way of fetching data in React. Here, we're going to export default function old here like this. We're going to return a simple div with the text of old here. Then head over to the page.tsx here. And inside it, just change the hello world text to the component that we just created, old, and import it here like this. As you can see here, our component is loaded here. If we head over to our old component here, we are going to fetch some data from the server, the mock backend that we just talked about, and load some posts from the server. So what we want here? First of all, we need a variable which holds our posts like this. We're using the React useState here like this, is equal to useState, which by start is an empty list and is of type post, which is going to be an array. But we did not define it yet. So head over to the File Explorer here. Inside your app folder, create another folder called types here. Inside that, create a file called post.ts, and we are going to define an interface for our post. Very simple, like this. Each post has an ID like this, a string, and also a title, which is of type string also. After we define our interface, we head over to the old component here. Then we import the post interface for errors to gone. We are going to fetch some data from the server. Because of that, we are going to use the use effect hook from the React like this. And simply we are going to fetch from our backend like this, which is on my local host port 8080 and on the endpoint of posts. we can handle the loading state like this. If no posts, we're going to return a p paragraph with the text of loading like this. And inside the return, we're going to create an unordered list here like this. And inside that, we are going to map over the posts that we just fetched from the server. Post, and for each post, I'm going to return a simple list item with the text of post.title. Don't forget to put the key here, which is post.id. If we head over to our application here, we can see that we forgot to use the use client directive at the top of our application. We head over to the top of our old component and we simply put the use client directive on the top of our component. I just forgot to use the response data here. After we fetched our data from the server, then I'm going to use the response like this and get the JSON part of it. Then I'm going to get the data like this. And after that, I'm going to set the posts, the data like this. A very simple use effect here. Don't forget to put the dependencies here. If I refresh my application, I don't see any loading state, because I forgot to put the .links here. And if I refresh my application, first, when there is no post, I know that my posts are loading. And keep that in mind that our fake backend has a delay of 500 milliseconds to simulate the real world use cases. All of this code was necessary to fetch the data from the server here, then set the posts like this, then show them to the user. And this way of fetching data from the server is pretty common and there is nothing wrong with it. But if we want to handle errors, timeouts, retries, refetch, Windows focus, and many other things related to the request, we must handle one by one like this, which is so hard to do and maintain. And if we want to use this data here in another component, we must pass it to that component as props, as children, or again fetch this data in that component, which we are making a single request twice, which is not very performant at all. The SWR library is here to rescue us from this mess, and our next step is to create this component with the help of SWR library. So we just need to head over to our components folder here. Then we need to create another component called post.tsx, and inside that we're going to export default posts, and I forgot to put the function here, and we simply put posts here. Then we head over to our page.tsx file. I'm going to comment this old component here. Then we are going to import the new posts component that we just created. And then we simply head over to our post component and let's create our first query to our backend for the first time. For simplicity, I'm going to create a folder called services here in my app folder, and everything related to the data, the server data, is going to be inside this folder. But before we create anything new here, we just need to head over to our terminal here. I'm going to stop my development server. Then I'm going to install Axios for our HTTP client and also the SWR library also. I'm going to install them here. After that, they're installed, just again run the development server. The convention of using SWR is to create a very simple fetcher function, which is also recommended by the authors of the package. So we head over to our services folder, and then we are going to create a new file called fetcher.ts. Inside this file here, first of all, I'm going to create a simple Axios instance like this, export cons Axios instance, because for each time that I'm going to use Axios, I don't want to repeat myself and create a new Axios instance. Is equal to Axios dot, I'm going to import the Axios. I'm going to import the Axios like this, import Axios from Axios, then dot create, and inside the object, I'm going to use the HTTP localhost 8080 for my base URL here. And then below this const, I'm going to create a simple fetcher function like this, which is going to get a simple URL, which you are going to understand it a little bit later in this tutorial. Then I'm going to return Axios instance. Let me just make it a little bit smaller. Axios instance, this instance here, dot get the URL which we are passing here. Then we are getting our response here like this and pass to this callback function and return the response.data. This function, the return of the fetcher function, this here must be a promise returning function to fetch your data here. And below this fetcher here, I'm going to export it as default export here. The question you may have is that why we don't just use the native fetch instead of Axios fetch? Because Axios library provides us with so many features like throwing and catching errors very easily. We can create multiple instances, we can have interceptors and so much more. But if you prefer the native fetch function, you can easily use it here. Just instead of Axios instance.get, we're going to put fetch here. And that's it for our fetcher. Now by having this, each time that we want to fetch the data from the server, we need to do something like this. Is equal to useSWR, which is a hook provided by the SWR library, which I'm going to import it from SWR, like this, import useSWR from SWR here. And inside that, first I need to pass a key, or in other words, our endpoint. For example, I want to get my posts here, but each time that I'm going to use this hook here, I'm going to also pass the fetcher function like this, which it's very repetitive and not the best solution. To solve this, we need to remove this here and also this, and we just need to simply create a file here called, for example, providers.tsx, and inside that I'm going to export default function providers, which is going to get the children, which is of type children React node. Then I'm going to return this here, SWRConfig, which today my IntelliSense is not working. I don't know why. I'm going to import it from SWRConfig from SWR here like this, and inside that I'm going to pass my children like this. The children is going to be our whole application. How to do it? Just head over to your layout.tsx file, or if you are using a simple React project, just head over to your main.tsx file and wrap your children or application here inside the providers file that you just created, like this. Then just head over to your providers here. Just don't forget to use the use client directive at the top of your component to not get any errors. And now you can configure your whole SWR queries, mutations, and many other things related to the SWR here. For example, I'm going to use the value prop here, and inside that I'm going to put my fetcher that I just created inside the services folder here. I'm going to import it, and because of this, there's no need for me to pass fetcher each time that I'm going to use the useSWR hook, which I showed you before. You can also use the syntax here, but I prefer this one. It's a little bit shorter. If you have seen my Tanstack query or React query library tutorial on my previous video, most of these settings or configs make sense. For example, here at the global level, for example, I can change the refresh interval to, for example, 3000 milliseconds. What does it mean? It means that your queries are gonna to be refetched each 3 seconds, which, for example, may be useful. For example, if you have a very data sensitive application which your data needs to be always refreshed and updated. This library, the concept behind this is very, very similar to React query or Tanstack query, which if you like to, you can simply check my previous video on it. We have also many settings which you can later play with them. For example, I can change the revalidate if stale to false. Why we want to do this? Imagine that your website data is not immutable. For example, you have a simple blog website which the data is not going to change. For example, and you can simply set the revalidate if stale here to false for SWR to not fetch your data again and again on different situations. We have other settings like revalidate and focus. For example, I can change it to false here. What does it mean? Imagine that your user leaves your application page. For example, he heads over to another page or changes his cursor focus to another application in his OS. And he then came back to the page, to your website page or application page, and the SWR library is smart enough to notice that, and when the user focuses in other way, for example, clicks on your page, the data is going to fetch again without the user even noticing it, because the refreshing is happening in the background. You're going to understand this a little bit later. We have other settings like revalidate and reconnect, which for example, we don't want to have it if our application is not very data focused, but for the sake of this tutorial, I'm going to comment this here, and I just simply pass the fetcher function at the global level for my entire application. After that, we wrapped our application inside this SWRConfig here and here like this. We can simply head over to our services folder here. Just let me close it and close this. Head over to your services folder and create a simple file called queries here for better organization, queries.ts, which we are going to put all things related to data fetching in this file. In this file, we are going to implement everything related to data fetching here. For example, imagine that you have an e-commerce website that user can have a very, very simple shopping cart. I'm going to use export function and I'm going to create a custom hook. For example, I'm going to call it use cart here like this, and simply I'm going to return use SWR from SWR package here. Then I'm going to pass something as arguments here, but first of all I need to pass the type of the return of this hook, which is going to be a simple cart, which I didn't define it yet. So head over to your types folder and create a simple file called cart.ts, and then inside that just export a very, very simple interface called cart, which is going to have a field called total cost here, which is going to be a string, and also the products, which is going to be an array of strings. Very, very simple. And head over to your queries file, then import the cart interface, and then just pass the cart here. But why we use cart here? As you know, we wrapped our application inside provider. The provider is here. This SWRConfig provider is using a fetcher by default, which we defined it earlier too. If I head over to the fetcher here, I can see that the base URL of my Axios instance, or in other words, the fetcher is HTTP localhost 8080. What does it mean? Is that if I put a /cart here, I simply requesting the address of HTTP localhost 8080/cart, which is going to return the data from my mock backend here. As you can see, the backend is running. And if I hit the cart endpoint, I simply going to have this data here, the total cost here and the products, which is this array. So how to use this data? Just head over to your components folder. I just made a mistake and created this post component a little bit earlier in the tutorial. Just forget it for now and create a simple component called cart.tsx. Export default function cart like this and return a simple cart here. Then head over to your page.tsx file, comment this post to, and here just import the component that you just created like this. Inside this component, I want to show the user his cart data. How to? Very, very simple. With the hook that we just created earlier. For example, const cart query is equal to the use cart hook that I just created. Where is this? This is exactly returning this hook here. We could have simply put this here like this, but it's not very usable and very maintainable, because each time that we want to fetch the cart data from the server, we need to define it here like this each time, and it's pretty repetitive. And because of that, we are simply creating custom hooks for our queries. Now, inside my div, I'm going to show user the data of my query, cart query.data. And now I have access to the product, which I define it wrong. If I head over to the cart interface, I'm going to change the product to products for you to see better. Then I can access to the products or total cost and so much more. But if we head over to our application here, we see that we're getting an error because we forgot to use client directive at the top of our application also. As you can see here, this is exactly the data that we want to show the user here. I refresh the page. I see this here. This way of fetching data using SWR is pretty common. What if we want to expand its capabilities to the maximum? For example, imagine that you have another query that is dependent to this query and vice versa. Imagine that first your user enters the page. Then before the cart even gets start to load, we need the user authentication data. I mean, first we need to load the user, then with the data that we fetch from the user query, we simply then can load the user's cart. Let me just explain it to you more clear. Just head over to your queries file here and simply create a very simple hook called useUser, which is going to return useSWR and our user, and it's going to have the return type of user. And as before, just head over to your types folder, create a file called user.ts and export a very simple interface called user. Just replace this interface type and you will get it in a second. The type user is equal to this object here, user name, which is going to be of type string, and maybe our user is going to be undefined here. Use type here so we can use undefined by our user also, because the interface didn't allow us to do, which is related to TypeScript, not SWR at all. Then we head over to our queries file, we import it here, and that's it. As you can see here, our both useCart and user hooks are here. Our goal was to make this useCart query dependent to this query. By other words, we mean that first of all, we need our useUser hook, or our user is fetched before we get the user's cart. It's pretty much simple with this library. How to do it? Inside my useCart, I'm going to use the useUser hook like this. Const is equal to useUser, and I simply can the data error is loading, is validating, and mutate from the useUser, or simply I can use, for example, user query here, and then over it I can use user query dot, for example, data error and so much. But I prefer this syntax here because I only need the data here. What does it mean? And according to this data, if it is available, it means that I have an authenticated user. And if don't, I simply don't want to fetch this query here, my use cart here. How to do it? Very much simple. I'm going to say if data is present, fetch this endpoint. Or in other words, or if there's no data, in other words, if the user is undefined, just return null. What does it mean? It means that if the data is available, we're going to simply run the query here, the /cart endpoint, and if there is no data, we're simply going to return null. This is a convention recommended by SWR library itself, which whenever we don't want our query to be enabled, or in other words, we don't want our query to be fetched, we simply need to somehow put null in our useSWR hook. So if user is present, we simply run the query, and if the user is not present, we're simply going to return null and the query won't run. So if you head over to our cart component, I can also import the useUser hook like this, user query is equal to useUser, which I don't want it here because I implemented inside my useCart, but for better demonstration, I'm going to use it here also. I'm going to wrap this data here inside a paragraph here, and above it, I'm going to put a paragraph, and inside it, I'm going to use the text, for example, username, and a space here, and if user query is loading, then I'm going to return loading text here. Otherwise, show my user query the data.username here. If I show you my application here, if I refresh the page, the behavior is exactly that we want. First, the user is loading. It's happening so fast because there is only a 500 millisecond delay, but you get the idea. First, the username is loading. When the user is loaded, just pay attention. When the user is loaded, after that, the cart is going to be fetched, which is exactly that we wanted. For better behavior, we simply can extend it. For example, inside this paragraph here, I'm going to put the text total cart cost and a space like this. And just let me remove this one here and open the curly braces here, cart query data. If this here is not null, is defined, I'm going to return the cart query data.total cost like this. Else, if cart query is loading, I'm going to return the loading, and otherwise it means that there's no user found. Still the user is fetching from the server, so I'm going to put no user found. If I head over to my application, I refresh the page, you can see when the user is loading, we simply get the no user found. After the user is loaded, we then have our cart cost here like this. This was our first implementation of SWR library. We saw how to create a simple query like this, and we learned how to chain our queries like this, our dependent queries. For the next part, we are going to learn one of the most important fundamentals of the SWR library, the mutations. To do that, first, we need to create a products query. To do that, we head over to our queries file here. Then we create a use products book like this. As before, inside it, we're going to return use SWR product array, and the endpoint is products like this. I forgot to use generic here. Then I need to define the product type here, product.ts, which is a very simple type like this. Export interface product ID is number, the title is string. That's it, and here we need to import it, and that's for our query. Then we head over to the components folder and create a new component called products.tsx. Export default function products, return simple div like this. Then we head over to our page.tsx file. I comment the cart component like this. Then I'm going to import the products component like this. Then inside it, I want to show the user the list of our products. To do that, I'm going to get the data from the use products hook that we just defined. I'm going to get the data like this. Then in the render function, I'm going to return a paragraph products like this. Then below it, I'm going to create an unordered list. I'm going to map over the data like this. Each item is one of my products, and I'm going to return each product as a list item like this, product.title, and I'm going to use the ID for my key, product.id. That's it. As you can see here, we have an error here. We can simply solve it by using a use client directive at top of our file. As you can see here, after 0.5 seconds, after 500 milliseconds, our products are loaded. Imagine that we could add new product to this products list. How to do it? With this, one of the most amazing features of this library is handling server mutations and revalidations. How to do it? One way of doing it, and because of that, I need to create a very simple form for my component like this. Input, and the placeholder of my input is going to be product title. The value is going to be input value, which I didn't define it yet. On change is handle update input value. For the submit button, I'm going to use this button like this with the text of create for now. On click of this button, I want to create my product like this with the help of this function. And that's it for now. I head over to the top of my component here. First, I need to define the input value like this. Input value, set input value is equal to user state with the initial value of an empty string. To update my input field, I'm going to create a very simple handler function like this. Const handle update input value is equal to e, which is of type change event HTML input element like this. And inside it, I'm going to set input value by e.target.value, which I need to import it from React here. And for this function here, I'm going to create my submit function like this. Const handle create product is equal to async. And inside the arrow function, I'm going to await Axios instance.post to the products endpoint because I want to create a new product on my backend. And for the arguments, I'm going to pass the title as input value like this. If we check our application here, if I add a new product, for example, microphone, and if I click on create, we see that there's nothing new. But if I head over to my backend, fake backend here, I see that new microphone is added here. If I head over to the front side of the application, you see that we again focused on our web page here. The SWR library is smart enough to revalidate our product query unfocused. But this is not the behavior that we want, because if I add another product like this, for example, camera, you see again the product is added to the backend, but the products query is not validated yet. What we need to do here is to get the mutate function from our query here, then call it after this promise is resolved, like this, mutate, like this. And now if I create a new product, for example, camera 2, and hit on create, we see that our camera 2 has been added to the server, then the products list got revalidated. But I do not prefer this way of mutating the server state on SWR because it's not best practice. And sometimes I may forget to use the mutate function here. And at the end, the user might see outdated data in the application. To solve this, I need to create a new file in the services folder called mutations.ts. Then inside it, I'm going to create a hook like this, export function, use create product. And inside it, first, I need to use my products hook here in my mutations, in my use create product mutation here, like this, const mutate is equal to use products, like this. Then I'm going to return another hook from SWR like this, use SWRMutation like this. And for the key, I'm going to pass the key of the use products hook, which we have defined it here, products here. For the next argument, we need to put a function here that is responsible for changing the state on our server. Because of that, I need to create another simple file here called, for example, api.ts here. And inside that, I'm going to put all the logics about mutating the server state. For example, I'm going to put my post requests, delete requests, and so on in this file. Export const create product. It's not a hook, it's a simple function, simple async function like this. And inside the R function, I'm going to await Axios instance.post URL, and the title is arg.title. Where did this come from? From here. For the arguments of our function, for the first argument, I'm going to put URL here. And for the second argument, I'm going to create an object like this, which the type is arg title string. It's a little bit strange, but this is the way that mutating is SWR is working. How to use this function? This is gonna make sense in a second. I'm going to put this function side by side of my mutation hook here. I'm going to make it a little bit smaller for you to see all of it. Then inside it, I'm going to put my create product function, this function here, and that's it for now. As you can see here, this way of using create product is exactly equivalent to this. On the second argument here of use SWRMutation hook from the SWR library, we are getting two arguments. First is a URL, which is provided by the SWR, which is gonna be this one here. The mistake that I made earlier that I told you, this must be the key of this use product query function here, but it's not. It must be the URL that you are gonna mutate the server state from that, and it doesn't have any relationship between the URL and it doesn't have any relationship with the key of our use product query here, this key. So as I was talking about, the first argument is URL, is exactly this, which is going to pass to this callback function as arguments. And the second argument is gonna be the arg. And if I put them here, let me make it a little bit smaller. If I put them here as URL and arg, we see that errors are gone. So for simplicity, I'm going to remove them from here. So by this way of using mutations in SWR, we have access to the arguments that we are going to pass to our trigger function, the trigger function, in a moment. But for now, let me just finish the use SWRMutation hook here by introducing you the callbacks here. We have many different lifecycle for our use SWRMutation hook. For example, we can do something on error, on success. We can use optimistic data, which we're going to learn it after this section. We can roll back our previous data if any error occurred, and so much other options. But the most important ones are first on error, which has these arguments, the error, the key, which is here, and the global config, but we don't need any of them. So I'm going to remove all of them. Then inside it, for example, I can log the error on the console like this, for example, error. And on success here, I'm going to do something very important here. Remember that we imported the mutate from our use products. We can use it here. Mutate like this. What is this code gonna do? First, the code is going to call this function, exactly this function, with the arguments that we are going to pass to our trigger function, which we haven't used it yet. And according to the result of this function, we're going to see different life cycles. For example, if an error occurs in this function, this one will run. And if the mutation here is successful, this function, this unsuccess will run. And if our mutation is successful, we can simply call the mutate from our queries here. Let me just close this. As you can see, we have our mutation here. And in our products file, we have our handle create product that we just defined earlier. As you saw earlier, we passed the mutate function after that our mutation is done, but it was not very best practice, so we decided to use this type of implementing. But how to use this one in this component? It's pretty straightforward. First, I need to comment these lines here. I'm going to import my useCreateProduct hook here. Let me just close this one here, and I'm going to make it bigger for you to see better. useCreateProduct here. And I'm going to get the trigger and is mutating from this hook here. Then inside the handle create product here, I'm going to use trigger function. And if I open the curly braces here, I can see the title here. Where does this title come from? From a create product function that we just defined earlier. As you can see here, you must use this exactly this here to get the title here. For example, I can change it to, I don't know, the price. And after that, it's telling me that you must provide here the price. But it was just an example. I need to put the title here. So as a title of my product, I'm going to put the input value, this value here, input value. And now if we check our application here, we see that if I, for example, create a new product, we see that the product list is validated also. But this way of mutating and revalidating is not pretty something amazing here, but we can make it amazing by simply using the optimistic UI traits. But what do we mean by optimistic data or optimistic UI? Imagine that you are creating a new product here, but if we click on create here, we have a little bit delay for my request to be sent to the backend and for the list of my products to be fetched again. This may take a few seconds to do on a real-world application, but if we have the title of our product here, for example, I have the product title of phone 5 here. What if we want to show the user the phone 5 in our products list? Immediately, we clicked on the create button without any delay. It's pretty simple with the help of this library. If you didn't understand what do I mean by optimistic UI, you're gonna get it in a few moments here. For the second argument of my trigger function, I can use optimistic data, which is gonna get the data of my products. This data is a list of my products here. But why do we need this? Imagine that you're creating the phone 6 product here. The thing that I want to do here is that I want to take all previous products, then add the new product to this list. So I need the old products list data. And if the data is defined, I'm going to return an array which I want to get all the data, all my products, and append to it the new product like this. The title is gonna be of type input value like this. But for you to better see it, I'm going to use a string format like this, input value, and I'm going to simply put optimistic data in front of it. You're gonna get it in a moment. And now if I create a new product, as you saw, first optimistic data is showing to the user. If I do it again, I see optimistic data in the list before the new list is fetched from the server, which is a pretty good practice in modern web development. And if I delete this optimistic data from this, for example, if I create the font-end product here, I can see that exactly the same time that I create the product, my list is updated, which has an amazing user experience. But a very important thing to consider is to always use RollBackOnError to true, because imagine that I create the font 12 here, and if I click on create here, the font 12 is immediately added to my products list here, like this. But the few seconds or moments is my optimistic data. And imagine that creating the new product was not successful and the server state didn't change. So what do we want to do? If an error occurs on our trigger function, I'm going to roll back on my previous data here. And this logic is completely handled automatically by SWR library if you put true on RollBackOnError here. But we can simply enhance the user experience more by doing some little tweaks here. For example, I want to disable the create button when a new mutation is running or the products list is invalidating, which I forgot to import it from the use products book here, is validating, and we previously got the is mutating from use create product. And now if I create a new product like this, I can see that the button is disabled when the query is running and the data is revalidating. And also I want to change the text of this button to, for example, if the mutation is running or the query is validating, then I'm going to return the creating text. Otherwise, I'm going to change it to create a product. Is mutating here is a correct word. Phone, for example, 14 here. As you can see, everything is working the way that we want. That's pretty much all of it about mutating in SWR. It's very simple, but very powerful and very, very easy to maintain on larger scale applications. Another cool feature of this library is creating simple middlewares. For example, I create a folder here in my app folder called, for example, utils, and inside that I'm going to create a very, very simple logger function, and inside this I'm going to export function logger, which is going to get an argument. For example, I call it SWR next, which is of type any. If you have worked with Express or Node.js, you're pretty familiar with next and with the concept of it, but we do not need to know them here. I just want to simply point it out. It's not a very special thing, but I want to show you that we can do it in this library very easily. I'm going to open the curly braces here. Inside, I'm going to return key, which is of type any, the fetcher, which is of type any, and the config, which is also of type any. But if you want to use it in a larger scale application, please use the correct types. But for the sake of this tutorial, I'm going to put any for all types for my logger. And then I'm going to again open the curly braces here, and I'm going to define const extended fetcher, which is equal to args here like this. And then I'm going to open the curly braces again, and then I'm going to do the thing that I want to do before each query is called. For example, I'm going to put the SW request, and for the value of this slug, for example, I want to put the key. We're gonna understand it in a moment by using it. And then after that, I'm going to return my fetcher or the request that was being initialized. And for the arguments, I'm going to put the args here. And after that, I'm going to call the next hook like this, use SWR next. I'm going to pass the key, the extended fetcher, and also the config file here. Just put any array here for error to be gone. And if you want to use this logger, it's pretty simple. For example, imagine that I want to use this logger on my products query. So if I head over to my queries here, and then I simply put the use, and I'm going to put the logger here like this. And now if I open my browser console here, and if I refresh my page, you see that our logger is working. it is showing us SWR request here, exactly like this, and the key of our query in front of it, which is exactly the behavior that we want. And we can also put many other things here. For example, we can append our authorization token to our request before we send it to our backend, and so much more. For the next part of the tutorial, we are going to learn how to use pagination in SWR. For that, if you remember, we created a post component earlier and we have so much things to do with it. For that, first of all, I need to create a simple hook for my posts. To do that, I head over to my queries.ts file, then I'm going to export function use post like this. And after that, I'm going to open the curly braces here like this. And after that, I'm going to return my hook as before like this, SWR, which is going to be of type an array of posts like this. Import it from here. And for the key, I'm going to just use the post endpoint of my backend service like this. And now if I head over to my post component, then I can use it here like this as before, use posts like this. And I'm going to get the data, the error, and is loading. In SWR library, I can simply do something like this. For example, if the query is loading, I'm going to return a loading paragraph here like this. If there is an error like this, I'm going to return the paragraph error here. And after that, I'm going to map over my post like this. I'm going to change it to a UL. Then inside it, I'm going to map over my data like this. It's undefined post. And for the render, I'm going to put a list item. For key, I'm going to use post.id. Then for the content of this, I'm going to put, for example, title is equal to post.title like this. And I'm going to use paragraph for this component like this. Let me just remove this extra space here, and that's it. And after that, we're going to go to the page.tsx file here. Then I'm going to uncomment this post component here. Then if you open our browser like this, we see that we have an error. It's because we forgot to use client directive above it. And after that, we can see that our posts are loaded here. If I refresh again, we see it's loading here first. And after the data is loaded, we see this return here. This wasn't new, but we need this for the pagination part. For simplicity, I'm going to create a post wrapper component like this. You're gonna understanding in a second that why we use the post wrapper here. Just wait a moment. In this component, first, I need to use a use client directive at the top of my file. Then I'm going to export default function posts wrapper, and inside the function, first I'm going to define the page index of my application state like this. Set page index is equal to use state, and for the initial value I'm going to use 1. Then in the return function here, I'm going to return the posts component here like this. And now we need to somehow tell our post component from our post wrapper component to change the page index, but the post component doesn't have any information about this page index here. How to do it? We simply head over to our post component here, and after that we simply define the page index props like this, page index, which is of type number. Then we need to pass this page index to my usePost query. But as you can see here, it throws us an error because the usePost query that we defined before doesn't accept any page index. So we simply add it here like this. And we need to fetch our data here by the page index. How to use it here? We simply need to change this key here that it contains our page index too. To do that, I'm going to use the previous post as before. Then my API has this structure. I can limit each page to 3 items per page. And for the page that I'm going to get from an API, I'm going to put the page index that I'm going to get from here, before that from here, and at the parent level from our post wrapper here. Then I'm going to simply pass the page index from my post wrapper here like this. And after this, I need to simply put 2 buttons to handle the pagination. This is the previous page, and then this is the next page here. And for the onClick, I'm going to set page index to page index +1. Sorry, -1, because it's a previous page. And for the next button, As it's very obvious, I'm going to set page index to page index plus 1. If we head over to our application, we see that we forgot to import our post wrapper. I need to uncomment this post here. Then I'm going to import the post wrapper component here. And if I refresh my page, we see that in each page, as I defined earlier from the use post query here, in each page, I'm going to have 3 items based on my page index. Where does this page index come from? From my post wrapper here. And when I click on next button, the page index changes from 1 to 2, and my API returns me the second page of my data. As you can see, between each request, we have a response delay, but if we hit the previous button here, we see that previous loaded data is cached and we can easily navigate through the pages without the user to see the loading state. But if we again open a new page, we see that we have loading state there. And there is another very cool trick. Let me just refresh my page here. As you can see here, if the user clicks on next button, he goes to the next page while he sees the loading state. If I hit it again, you see that we have loading state there, but we can solve it. Let me just refresh it again. We need to somehow load the next page data while user is in the current page. How to do it? It's pretty simple. Just below this post here, I'm going to create a div tag here. Inside it, I'm going to again put my posts component here. Then I'm going to pass the page index of page index plus 1 because it is the next page and I simply can't hide it like this, display to none. And if I refresh the page now, we see that behind the scenes, the next page is loading on the current page, which is an amazing user experience here. For the next part of the tutorial, we are going to learn how to use infinite scrolling as you see on different social medias, for example, Instagram or YouTube. As you scroll down, the new data will be fetched and will be added to the previous data. It's pretty simple by the use of this library. I need to create another component called, for example, todos.tsx, and I'm going to export default function todos here like this. Return a simple default with the content of todos here. Then I need to go to my page.tsx file, comment this, and import my todos component here like this. And now if I head over to my todos component, as before, we need to simply load our todos here. Because of that, I'm going to head over to my queries file here. Here, I need to define my useTodos hook here, export function useTodos, which doesn't accept any parameters. Inside this function, I need to define a getKey constant here, getKey, which will be going to return the key for my infinite scrolling hook. What does it mean? Let me just assign the empty string to this getKey constant here, and for the return of my hook, I'm going to use useSWRInfinite hook like this. And for the parameter of this hook, I'm going to pass the getKey here, and because I'm using the TypeScript here, I need to pass the type of my todo also. Let me just define it here very quickly. Export interface todo. For the body of this interface, I'm going to define ID as number, checked as boolean because each to do is whether checked or not. For the title, I'm going to put a string, and for the description, I'm going to put a string also. Then head over to the queries here, then import it like this. But we need to define our getKey constant here like this. First of all, it's going to be an arrow function like this. Then as first argument, I'm going to pass the number, the page index as a number. You might think that this is infinite scrolling and it's not pagination, but why we use page index here? Because as you know, if we scroll down, new pages are loading as the user scrolls down, and each part of the UI that is loading will going to have an index that by them we simply get the data from the server, but that page index. So keep that in mind that even in pagination and infinite scrolling, you're always gonna have the page index parameter for our hook, for our useSWR hook. For the second parameter, I'm going to put previous page data, which is going to be of type todos array. And inside this function, I'm going to say if previous page data is existing, and if the previous data dot length is null, I'm simply return null here for my getKey, and otherwise I'm going to return my query key like this. Todos page is equal to, the page index. And for the limit as before, for example, I need to pass the 3 here. And as you can see here, the error is gone now. And if I head over to my to-dos component, I can simply use the hook that I created, the infinite hook, const data and set size, and also the size is equal to use to-dos here. But where did this come from? The set size and size, they come from the useSWRInfinite hook from SWR library, which we are going to use them in a second. Now, I simply, for example, can say if there is no data, simply return loading. Otherwise, in my div, I'm going to map over the data, and each iteration, I'm going to have not a single to-do, but a list of to-dos here like this. I open the curly braces, I'm going to return again. I'm going to map over these to-dos here, .map, and now in each iteration, I'm going to have a simple to-do like this. To-do is equal to div. For the key, I'm going to use to-do.id. And for the content of this to-do, I'm going to put simply to-do.title. And I simply need to put a load more button here, load more. And on the onclick of this function, I simply set size to size +1 as we imported them from the useToDo's query hook. And now if you head over to our application here, we see that I always forget to use client directive at the top of my component here. And as you can see here, if I refresh the page, first we see this loading here, and after the data is loaded, we see 3 items per each page. And now if I hit on load more here, after a delay of 500 milliseconds, we see that new data is loaded. If I hit it again, you see the new data is attached to the list of my data. But I realized that there was a problem with my backend paging index because it starts at 1 index, but using infinite hook, it starts at 1. So I simply added a +1 to this get key here. And if I refresh the page here, if I hit on load more, we can see that the new data is loaded. And now there's no more data here to load. And that's it for our infinite scrolling here. I hope you have enjoyed this video. Do not forget to subscribe to my channel and like this video, as it really helps my career on YouTube to continue. I hope you have learned something new, and see you later.